The MENS project, ladies and gentlemen, which was funded by the Research Südtirol Alto Adige 2019 program and led by Professors Mario Clara and Diego Calvanese, pursued two independent but interconnected goals. The first being a classical collection of and investigation into medieval medical, theological, philosophical, and other texts dealing with the human brain. One of the major aspects of the second, the digital humanities goal, was experimenting with keyword spotting functions in order to screen larger amounts of manuscript image data for specific content without having a correct transcription of the manuscript text. The now shut down keyword spotting function in Transkribus made it possible to search for words in texts that were automatically recognized using a SITLab HDR+ model. In contrast to full text search, keyword spotting is able to find the searched for words even if they are spelled incorrectly in the transcription. This is possible because the tool uses all probability values for each character and not only the most probable result. The recognized text shows only the characters with the highest probability value, but the keyword spotting function considers the values for the second, third, fourth, etc. most probable character as well. Besides, the searched for keyword extracted information for each search result includes the document, the page number, and the line in which the keyword was found, as well as the transcription of the line and a confidence value between 0 and 1 that represents the accuracy of the tool in finding the searched for word. The higher the confidence value is, the higher the probability that the result coincides with the request. The sample corpus, which formed the basis of our investigations, consisted of the 260 manuscripts from the Vatican Library's Codices Palatini Latini collection with medical content, which comprise more than 100,000 manuscript pages. To give you a small impression of our results, Aaron and I have selected two of the 260 medical manuscripts examined by us, namely Pallat 1111 and Pallat 1118. Both manuscripts contain Avicenna's little work on the powers of the heart, De Viribus Cordis, that deals with the so-called animal spirit originating from the heart, with the passions of the heart as well as cardiac remedies. So what have we done? We HDR'd the respective manuscripts, first with HDR+, later with PyLayer. In a next step, selected 6 keywords, 2 brain anatomical and 4 brain physiological ones, and finally ran the keyword spotting. Of course, not without first counting the number of each keyword in an online edition of Avicenna's De Viribus Cordis. The results of the keyword spotting were the following. For Codex Palatinus Latinus 1111, we got 194 hits with HDR+. There were 22 true positives, 172 false positives, and 24 false negatives. Later, working with PyLayer, there were 401 hits, 11 true positives, 390 false positives, and 35 false negatives. With Codex PALLAT 1118, the situation was as follows. With HDR plus, we had 149 hits, 35 true positives, 114 false positives, and 11 false negatives. Whereas with PyLiar, we had 535 hits in total, 25 true positives, 510 false positives, and 21 false negatives. Yeah, in view of this, the question naturally arises as to the usefulness and meaningfulness of an application of keyword spotting to a large amount of manuscripts in order to search for specific content in manuscripts. And now I would like to hand over to my colleague Aaron.
So our basic idea was to, as Hubert told you, to screen large amounts of manuscripts and then run the keyword spotting to check if these manuscripts deal with the specific content. And as our results weren't as promising as we hoped for, our idea was that if we plot all the results of the keywords in a diagram, and then if it worked, there should be a peak among those pages where the manuscript is dealing with that content. And in these diagrams, as you can see, there isn't that much of a peak. And in respect with the high amount of false positives and also false negatives, our idea did not work as we hoped for. And the question is if that approach even makes sense in order to check these texts for, as our validation set could not, well, confirm that it works as we hoped for. But we only checked these two manuscripts in detail. So there could be that just the model wasn't good enough for doing so, or just these two manuscripts weren't bad examples, and it could work for other manuscripts as well. But with our results, the keyword spotting function does not work as good as we hoped for screening large amount of manuscripts in which we don't know which content they deal with to look for that content.
Thank you.
Well, thank you very much. Who would like to get the microphone and ask some questions?
Thank you. Obviously, when applying your method when dealing with keyword spotting, the main issue are false positives, right? So could you tell us some more about your ideas how to reduce false positives?
So, well, the good news is that among the top positives, they're almost just true positives. So if you just look among, as we had here, the 400 hits of 401 hits, those 11, the top 10 or 7 true positives. So as the confidence value, low the confidence value, the more false positives. So if you just look at the top 10, top 20 results, you have a high percentage of true positives. So that works, but unfortunately we still have a large percentage, big percentage of false negatives. So if we increase the number, we will just get more false positives. So, but if you look at the top results, you will have almost just true positives. So it works in that sense. But unfortunately, you only get in that example just 1/4 of the result of the keywords that you should expect.
Other questions?
Have you tried comparing this to the performance of an LLM? Finding basically doing fuzzy search with an LLM?
So we didn't try that. So, but that would be another possibility. So, but we didn't do that, yeah.
How was the CER for those documents?
So we did not look for that. So we just took these manuscripts we had in a proper transcription of them. So we just the basic idea was that we have a generic model that we use and then run it over those 260 manuscripts. So without looking for how good the transcription actually is, that is to use a generic model without looking for a very specific transcription, because if we could transcribe it properly, then we could also use full text search. So that's was not the issue we were looking for.